Okay. Just work out how this goes. Okay, awesome. Yeah, hi. And yeah, thanks for listening to my talk today on XR with ArcGIS. So I want to talk a little bit about how we at Esri essentially sort of define XR, and then kind of what our solutions are that we offer to take your GIS data to different sorts of XR experiences. Hello. I'll just use that then. Okay, so first up, VR, so virtual reality. Essentially, this is always really awkward, but it's essentially being there, right? It's very immersive, and typically we think of it as being in the HMD, right, in your head-mounted display. And then there's AR, so augmented reality, which is this interaction with the outside world, and the way that we see that is with these mobile devices, so phones and tablets. So yeah, you can see in this demo, you've got, as you can see, this interaction with the outside world. So even also when this guy comes and opens the door, you know, it all still makes perfect sense. And then MR, so mixed reality, and thank you to the city of Zurich for this video, but it's this mixed presence, so typically like HoloLens or Magic Leap. And in this example here, you can see, you know, like building propositions overlaid on top of the real world thing. And obviously that makes it very graspable and very easy to understand. Yeah, so a little bit more about this terminology. So let's say when we talk about VR, there's different types of VR as well. So mobile VR, console VR, and premium VR. Obviously all have their pros and their cons. Mobile VR, it's relatively cheap, low price, you know, low entry barrier, broad reach because everyone has a phone. But on the other hand, you have obviously limited graphics, a limited bandwidth, and at the moment still only 3 degrees of freedom, so you can't walk around properly yet. And then you've got console VR, so easy to use, and actually I think the most used type of VR, but only used in the entertainment context, and it's this walled garden business model, so you obviously have to operate within, you know, Sony, PlayStation restrictions, and clearly for us, with ArcGIS, that's just not going to be the platform that's going to work. And then premium VR, so high cost, obviously, yeah, headsets and trackers, but also a good computer, and yeah, it's all very expensive. And it's complex to set up, so I'll get into that a little bit later too, but you know, you've got this, you've got cables, you've got trackers mounted, you've got to calibrate things, you have to know where everything is. So it's it's not just click and go. But good thing is that you have free movement, so once it is all set up, you can walk around within this space and it feels real. And you have advanced input capabilities. Yeah, I know I was just talking to you about this before. Then you have this issue about locomotion and teleportation. So what is the main reason that one of the main reasons why VR hasn't been adopted by everybody? And it's essentially, people get motion sick. So it really is a big problem when a lot of people put on the headset and it, you know, a couple seconds in or a couple minutes in, they're not feeling so good anymore. So there's certain ways to deal with this, whether it's like physically teleporting using a button, or like going through these sort of different viewports, essentially teleporting from viewport to viewport. So it's getting better, but it's still not like the ultimate solution, I guess. And here's just some sort of numbers to back this up. So at the moment, still 45% of VR experiences, they avoid locomotion altogether because people feel sick. And 42% use this teleportation that I was talking about before. And yeah, 5% use the gamepad teleportation. 8% use other techniques. So yeah, so when we talk about what sort of the gamepads or input devices, these are sort of the different, or you know, an example of the different ones that are out there. So on one hand, you've got the HTC Vive, and I'm assuming most of you here have had on some sort of a headset at some point in time, or you've played around with one of these consoles or many. But yeah, HTC Vive, and then the Sony PlayStation, Samsung up here. And then Leap Motion doesn't use any controllers. You just use your hands. And then on the right-hand side here, we have sort of a bit more, I guess, like specialized ways of getting input. So I think this is used sort of more in the military. And this guy's essentially walking or running on a treadmill to maneuver himself around his VR experience. And then this one I learned is actually a startup here in Zurich. And it's a seat that obviously you sit on and you sort of navigate around with your ass. So so it's all there. And then here's sort of, I guess, the other, if you're developing a VR experience, you have to make a decision for yourself, seated versus standing versus room scale. Obviously, if you're doing seated versus standing, or seated or standing, you don't have to deal with this. But if you want to create a proper, fully immersive, I guess, experience, you sort of do want to use something that's room scale. So you have to make some space and move some things around and think about where you want it to, because obviously you have to have a certain amount of meters available. And then you need to establish tracking. So here we go, grab the controllers. And you have to locate your monitor, because it needs to know where that is. And then you also have to calibrate the floor, so you locate the floor, and then you wait. And then obviously you need to know where you are, so you need to measure your space. So you walk around, you make sure you avoid all the furniture and every other thing that you have in the house. And essentially then once you've set your play area, then you're ready to go. So, and then obviously then it's great, because then you can move around within this space very freely. But it's just not so easy to get there at this point, right? And then, so now we have this sort of other way of doing good VR, or a good VR experience, and this is table scale or tabletop user experience. So instead of, just fully putting somebody in like a fully immersive experience, make it a bit more intuitive, a bit more relatable, a bit more approachable. So it's a collaborative experience. People can stand around a table. It's familiar. As I said, people can relate to the table. And because you're not fully in there, you don't have that motion sickness problem that you would have if you were immersed. And this is actually a video from GDC last month. So, I mean, these guys are playing a board game, which is relatable, right? Everyone's played a board game, and so sitting around a table in VR playing a board game. Which obviously from the outside just looks so weird. But, yeah, and so my next topic is just this positional tracking. So, why is it so cumbersome? Why do we have to set up everything to create this room scale experience, for example? So on the one hand, you've got outside-in tracking. So you place the cameras around different locations, and you have different markers on devices, and obviously you have your head-mounted display, and you have your controllers in your hand. And the good thing is, it's extendable. You can always get more trackers or buy better controllers and things like that. So it's scalable, but it's just, a lot of the time too with the trackers, you have to drill into a wall, you have to, place them, you have to make sure they're positioned correctly. And then on the other hand, you've got this inside-out experience, right? So headset, cameras going from the inside out, which gives you this markerless tracking. And obviously it knows where you are and it changes in relation to the environment. It's obviously a lot simpler and it's definitely the future, but there are still certain limitations. And we see that with phones as well. So you've got this problem of accuracy still. So, I mean, example for Pokemon Go, you've got a phone, you've got GPS or you've got Wi-Fi, but it's only accurate to a certain extent, right? And in a game like this, I guess it's not so important. But if you want to, I don't know, if you are looking at something or everyone's looking at a table, for example, you don't want to sort of be looking at different things, or things need to be in relation, especially when there's multiple people in the experience. So yes, so GPS only roughly 10 meters, and it only works outside. So even if it was more accurate, there's no point, you can't use it inside. Wi-Fi is only accurate to 2 meters, and beacon and RFID, you've got roughly 1 meter accuracy there. And so as with phones, you also have this issue of this same challenge in the headsets. So yes, there is inside-out motion tracking, but you need to all first calibrate and establish the initial position, as we can see here. So everyone, in order to actually be looking at the same thing, needs to first of all look down at the floor and calibrate the initial position. Yeah, so what solutions do we offer to create your XR experiences, or to go from GIS data to XR experiences? So now I can use this. There we go. So the first one I want to talk about briefly is this ArcGIS 360 VR. It's essentially, for lack of a better word, but like this one-click solution. So you go from your data, you import into CityEngine. CityEngine is sort of I guess, like a conductor for all three of these, but then export out of CityEngine into 3VR format. And then you have this out-of-the-box mobile VR currently for the Samsung Gear, and we're planning to also have it available for Oculus Go in the future. So yeah, so planned, not yet available. So it's a pretty easy way to go from GIS data to virtual reality. And then, Simon briefly talked about this just before. Then there's this Datasmith export format as well, which is this export format together with Epic Games or Unreal Engine. And so now coming out with the next CityEngine release, we've got this VR template for urban planning. So that's an already available template then for Unreal Engine. And that means that when you do export from CityEngine, I think you guys mentioned it before when you talked about Unity or exporting to Unity, like you don't have to with this template anymore. You don't have to worry about reassigning attributes and things like that. Once you've brought it into this template, everything will work. So you can just play around a little bit in Unreal Engine then to create the experience that you want to create. And then for those of you who want to go a little bit deeper again, so I'll just make a note here. So tomorrow, I think at 2 o'clock, my colleague Benjamin's got a workshop or live demo essentially on this topic. So I really think it's worth visiting. But basically as well, we can go from CityEngine, obviously Datasmith to Unreal Engine and FBX to Unity, to Game Engine as an XR development environment. And so you can see here as well, so for the future, we're planning streaming from ArcGIS Online or Enterprise into the game engines directly. So ArcGIS runtime plugins. And then, for those of you who want to develop natively, so it's .NET, iOS, or Android, you can do these offline stream packages into the ArcGIS runtime beta. So just quickly, here's an example of the 360 VR. So I export as 360 VR. You can select what you want to actually export, but you can just export everything. This is our office, where hopefully you'll all be tomorrow morning, so you can actually see it for real as well. And then so this is gone then from CityEngine into 3VR, and here we are. But you can see it's just this, it's a viewing experience, so you can't walk around, it's for mobile. So in order to get around here, we have this sort of teleportation that I mentioned before, where you select a bookmark, you teleport to the next room. Then this is this template that I mentioned. And here's this tabletop or table scale experience. You've got two people talking about proposed designs. It's relatable. Both of them can move the table around. Both of them can scale. And so we're putting on scenario number 1. So this is the first proposed design. Obviously, you can talk about it, point to things. Scenario number 2, and so on. And and I mentioned the runtime beta too. So for any of you who would like to learn more about it, then yeah, if you want to access the beta program, send an email to this email address. And yeah, that is me done. So thanks for listening. If you have any questions, let me know. Yes?
When you are looking at this, your tabletop experience, can you also jump into the city?
Why, yes, Simon, you can. I have a feeling you know that you can. Yeah, of course, if you want to really get that fully immersive experience, absolutely, you can jump into the experience, you can be on the streets, you can walk through the streets, you can look up at the buildings. So that's definitely possible as well.
Are you familiar with this a group of algorithms called SLAM? Simultaneous localization and mapping.
Nope.
So you mentioned mobile VR has only 3 degrees of freedom.
Yes.
Now we have AR Core and AR Kit.
Yes.
And with that you have 6 degrees of freedom. So you can actually map the environment and move.
I have a slide here on AR Core.
So are there any plans to export to these kind of environments using that technology?
The runtime is already using it. They're based on AR Car and AR Kit, so you can use that there. But I think there are not yet any more VR solution like for AR. I think that works, but for VR, I think there's nothing out there. Actually, it's not good enough. You're getting like if you would move around and if there's some lags, it's good for AR, but for VR, it's not. For example, the Oculus Go also is still just 3 degrees of freedom,
Yeah.
6.
Yeah. But for AR, it's good enough.
Yeah.
Right? Yeah.
We're supporting this. So yeah, I really recommend if you're into development, use